While we're doing that, I'll just give you a quick intro. I'm Neil McCormick. I'm the Global Product Development Manager for the Adjuvants and Biological Products. So I'm going to manage those two lines of business for FBN. And over the past couple of years, we've been doing a lot of work to really understand the market, bring to you guys a portfolio of products that you can understand and trust. So we're going to go through all the changes and that kind of thing there. So that's the context and what we're going to cover here today. So we'll get started in a second. I'll try to be kind of in between Alex Honnold's laid-back nature and then Jocko's intensity, so I'm going to try to land somewhere in between that. If you guys are, I can't quite get to Jocko's level, but I don't know if many of us can. So we'll give. Looks like we got a few in the back rolling in, so we'll give 15 more seconds and get started here. Yep, so what we're gonna cover is really trying to give you guys just a basic overview. What are adjuvants? What do they do? Why are they important? Why does quality matter? So what's the objective when we put an adjuvant in the tank? There's a lot of confusion. There's a lot of products. How do I pick the right one? So we did a lot of work to navigate that for you guys and make it simple and easy, and make sure you had the quality of products that you need to do the job you need to do. So let's start with what is an adjuvant? Why do we need it? So in the slide here, you can see on the right side, you have our product with an adjuvant. On the left, you have without an adjuvant, and you can just see the product's getting a lot more broadly spread across the leaf. That's your spreading, wetting, activator type activity. So it's pretty, the basic concept is I spend a lot of money on crop protection. You can see the $30 to $70 an acre on the left. And I need to spend that $1 to $4 an acre on the adjuvant to make sure that that active ingredient that I'm banking on to do its job, I'm spending a lot of money on. I want to make sure that that's performing and working because it's a high risk for it not to. You don't want to have to respray or do any of that type of thing. So what are the different things that can affect adjuvant performance? We start with chemical performance, wind, temperature, humidity, equipment, so our ground speed, boom height, spray nozzle, pump pressure. Water quality, so what's the hardness, pH, temperature, surface tension of water causes issues. As the formulation, is it a water-based versus an oil-based? Am I putting a contact or a systemic pesticide on? Is it a positive or negatively charged chemical? What's the adjuvant load? So do they have enough room in the formulation to put an adjuvant or not? So do I need to add more of it? Then also the plant itself, so it's got a thick waxy layer. What's the growth stage? Is there leaf hairs or leaf angles that I have to deal with that are preventing the droplet from staying on the leaf? So you can see from the time the chemical leaves the jug, goes into the tank, there's a ton of things that can happen and go wrong that are going to make that $30 to $70 an acre investment start to degrade over time. So that's going to, and then those are all your problems. So off-target drift, droplet evaporation, volatilization, poor coverage, mineral tie-up, low absorption, separation in the tank. So a ton of things, and those are all the problems that adjuvants are going to solve to make sure that you're preserving that high dollar investment in crop protection. You're not having to respray or do any of those types of things. So what did we focus on in building our portfolio or putting adjuvants together? So the science, so we wanted to have well-vetted products with sound agronomy. So make sure that it's doing what we're claiming it's doing. That what's on the jug is what it's actually performing in the field. Convenience, so easy to use products that aren't going to cause any issues, that are good quality formulations, that aren't going to separate, that are going to perform at the level that we want them to. And then the data, so understand and be able to have the data to back up the claims and what they do and understand when and where and how and why to use all the products that we have. So with that, we put a structure together called the Mixed Supply Perform that simplifies how we think about adjuvants and the different types of functions they can serve. So the mix, those are going to be your water conditioners and your utility products. We have just an AMS, then we have some low-rate alternative water conditioners, even DR and LR. We're going to have our utility products, which is anti-foam, spray tank cleaner, compatibility agent. Then getting into the apply, so the apply, once I leave the nozzle, clicker here. So once I leave the nozzle, how do I make sure that the droplet stays the right size to get to the plant? So that's your DRA, VRA products there. And then the perform is once it hits the leaf, how do I make sure that it spreads across the leaf and gets into the plant and kills the target pests that I'm trying to kill? So that's going to be your surfactants. We have two surfactants, Insorb 90 and then Insorb ADV. We'll get into the differences in a few slides. The oils, so crop oils would be in-plant and then in-plant advanced. We'll get into the differences there, and then your MSO products, so high-surf MSO and organosilicone MSO, and then your standard MSO product. Then the multifunction, if I want some convenience, I don't want to add 3 different products, I just want to add one. We have the Evenel Pro, Tether DC, and Tether 2.4. Again, we'll get into the differences, but that's the full and complete lineup of what we're offering at FBN with our revamped adjuvant products. And then the goal really is to be able to have a portfolio that matches, is equal, as good or better quality to the competitive products on the market. So we wanted to make sure that you're meeting that high bar that you guys expect from adjuvants at a really good price point, so without sacrificing quality. So a lot of good products out in the market today, and we wanted to make sure that we weren't giving you guys anything that was any lesser to a quality standard that we can be proud of. So the labels, Sophie up here and Steve are actually, I'm going to call them out because they put hours and hours of work in crafting really good labels that give you a lot of good, straightforward information. So we start with the general info, we put all the functions. So what is this adjuvant actually doing? And we put it right there where you can put, just quickly observe, well, it's a leaf and canopy penetrant, evaporation reduction, foliar retention, spreader wetter, then it's a non-ionic in nature. So I just wanted to give you, and then a brief description on the paragraph here below that's going to give you really good detailed information just to know why am I using this product or what is it actually accomplishing for me. Second is the rates. We just put a nice chart there to be able to give you a good label rate both in pints per 100 and then the V to V ratio. So easy to find and navigate there. Then also, okay, what's the mixing order? When do I put what where? So we have a really good mixing order chart. So if you get to the field, you're like, okay, well, I forget what to do. You can always pull out an adjuvant jug, just look right there and have that handy because it's tough to memorize all those different factors when you get out in the field. So tried to make, paying attention even to the small details like the label to make sure that not only is the product quality, but the information on the label is quality as well. So getting into the products, we'll start with the basic water conditioner 101. So why do we need water conditioners? Hard water, calcium, magnesium concentration. In the back there, you can see the higher or the brighter red it is, the harder the water. So pretty much virtually everywhere is going to have water hardness to some degree. Without that water conditioner, the calcium magnesium is going to bind to the negatively charged chemical. It can't get into the plant. So that's our AMS, and then AMS, you bind the ammonium to the chemical, and then the sulfate's going to bind to the calcium magnesium, and then that's going to prevent the binding there, and it's going to pull the chemical into the plant. And then our low rate products typically are just going to bind the calcium magnesium, so it's not going to have that ammonium activity that it doesn't. But it's more of a rate advantage, a convenience advantage with the lower rate type products. So those are the three. Why we just a basic 101. Why do we need water conditioners? So that even DR, LR, those are just going to be your low rate products where I want to get the majority of the performance, but not have to handle 50-pound bags of AMS all the time. So really convenience there, and then also our liquid product, just going to be LR, same thing. We're just trying to reduce the rate, be able to use a little less product. So convenience, and then from a price point of view, it's going to be pretty close, depends on the timing. AMS fluctuates quite a bit, but the price per acre should be on par, if not a little less for those products. So on a per gallon, per pound basis, it might be a little sticker shock, but on a per acre basis, you're going to be pretty similar. So that's our water conditioners, pretty basic. And then getting into spray droplets, really the objective is I need to keep the droplet the right size to be able to perform the objective that is it a soil applied herbicide, systemic contact, or contact. And the nozzle is going to do the majority of the work. You can see that blue chart in the bottom. You've probably all seen that if you bought spray nozzles before. That's a pretty universal chart there. So that's really the objective is how do I keep that droplet the same size? So we do the coarse tuning with our nozzle, then the DRA is going to be the fine tune. So how do I just want to make sure that I'm maintaining as much of that droplet size as I can so that the chemical can stay in the right form in the droplet. And then also reduce the driftable fines, so that's just the really small droplets that are not going to have any ability to carry the chemical that are a waste in our application. So that's just a unique chemistry that's going to bind and maintain that droplet size. So it just binds the droplets together to make sure that we're staying the right size. And then your drift potential, canopy penetration, that's your benefits you're gonna increase there. Then looking at competitive, interlock being one of the more prevalent competitive options out there. So we have some data showing equal performance at half rate of interlock. So from a really good value for members, we're going out at actually less per gallon, and then we have half rate, so you can save a lot of money without sacrificing any quality or any performance. So really good product. Very confident about this one, and something we're excited to bring to members. The clickers. Then we're just gonna do a quick DRA, VRA, everybody knows that one. It's hot and dry, volatilizes, so we had a VRA to stop that. So everybody knows that, it's an EPA requirement, so we all know that's a factor there. And then we're gonna get into the surfactants. So just a basic, what is a surfactant? Why do we need it? Water, beads, has a naturally high surface tension. So we had the surfactant to spread the droplet out. So when you think of the spreader wetter benefit, that's really the simple as it is. We just want to spread that droplet across the leaf and make sure that it doesn't dry, and then we get it to stay on the leaf as long as possible. So the Inzorb products, and then also some of our MSO, the high surf, the Organicil, are going to contain some surfactant properties. Here's a quick video just to give you a demonstration. It's pretty cool here, so we'll give it a little time. On the left is going to be the standard non-ionic surfactant. On the right is going to be the Inzorb Advanced. So we're just going to show you the difference in qualities and what this can accomplish. So on the left, you can start to see the distribution isn't quite as good. On the right, there's a lot more even distribution throughout the droplet, and it's getting out to the edges a lot further. And then as we go in time here, you're going to see the green rings start to form on the left, and it's going to dry the droplet out. So that's meaning the active ingredient isn't having as much, it doesn't have as much time to be able to get into the leaf. It doesn't have as much time on the plant. So for any contact products or something that needs a lot of time to really get the activity, you're not getting quite as good a benefit. And then on the right, you can see it's going to dry out, and the distribution of the droplets are further out. And it's just a lot better coverage. So that that there just an example of showing you what the benefit is and what the difference in a quality product. It's not something you can observe. If you just go out on a leaf and look at it, you're trying to judge what product is better. It's going to be pretty tough. Like, this is at a pretty microscopic level. So it really takes this kind of stuff to evaluate what is the benefit, or how is this product doing what it's supposed to do, or how is it better than another one. And then getting to MSO's oil products. So a lot of thick waxy layers. We're just trying to burn through that, or be able to get through that so that it can get into the leaf tissue. So penetrate the waxy cuticles, penetrant products. So high surf again, our MSOs, and then our oils are going to be the products to use there. So our implant advance, just a quick explanation on what that is, how it's different. So it's a soy-based material that's going to, instead of stripping the leaf wax, it's going to open the cuticles. So it's a lot more plant safe. You can use it at a lower rate. So it's going to, instead of trying to do that. So here's on this right is a standard crop oil. You're just trying to get the oil distributed throughout the formula. The implant advance is actually a smaller molecule size. It's going to go at the bottom of the droplet, and then it's going to open the cuticles and carry it into the plant. So it's a little bit different mode of action that just gives you a rate advantage, a plant safety advantage. So something we thought was pretty cool technology, and is just an alternative to a standard crop oil type product. And then our multifunction adjuvants, we have Evenel Pro. That's just our AMS plus drift and non-ionic surfactant. And then our tether DC is going to go with your dicamba products, so just a multifunction dicamba product, and then a tether 2,4 with dicamba as well. Something we're evaluating or looking at is combining when the tether DC is a VRA DRA, so something we're kicking tires and looking at for next season. So you don't have to use two products, but all either list improved or Tavium, Extend-to-Max, and Genie approved as well, respectively. Then just this is a cool video on the Evenel Pro versus standard AMS. So you can see on the leaf where on the right you have your standard AMS. So I've successfully solved my calcium magnesium issue, but then I want to also be able to get the droplets spread across the leaf evenly. So even though I've conditioned the water on the one on the right with my AMS, on the left, the chemical's not getting spread across the leaf, so I'm not getting as good of activity. So pretty cool example just to show you with The black light's pretty sweet, I think, so it kind of makes the point obvious. You know, it's something where if you're in the field trying to do this stuff, you're going 30 miles an hour in a sprayer, it's hard to slow down and look at that. And then, let's see here, get this one started. On the right, we're gonna have enlist. There we go. So we just have a deer cam footage. On the left is gonna be without an adjuvant, and on the right is gonna be with the Tether 2.4. We'll just let this one play out. So we're gonna see on the left, you'll start to, on the right, you'll start to see it slowly. The weeds are gonna die in between the rows a lot faster. So by the time you get to the end, you're gonna see a bare row in between, and on the left, you're gonna see quite a few weeds still remaining. So even though we're using the same product with enlist product on both sides, you know, the chemistry hasn't changed, but the adjuvant ratting is the only factor that's different. So you can see where even it's a high quality formulation, high quality dicamba product, it still takes that adjuvant to really, you know, de-risk, make sure I'm killing the chemical as fast, or killing the weed as fast as I can. So it's really that extra, you know, $1.50 an acre, $2, whatever, around that range, just to make sure that we're getting that activity faster. And then on the left, similar, so we just have Tether 2.4, so instead of the Evenel with the AMS, this is the AMS-free version. Same thing, you're just seeing better, on water hemp, you're just seeing better coverage there. So it just shows you what an adjuvant can do. Pretty simple form. And then, okay, you've covered what adjuvants are, what they do, why you need them. So how do I know, you know, one of the hardest parts is, well, how do I know what product to use with which chemistry? So usually you got to call somebody, you got to navigate the label, you know, there's a lot of different things. And, you know, it's hard to memorize all that. I know, Steve, you've been in adjuvants for 40 years and you don't have all the labels memorized yet. So that's all he does all day. So what we've done is we've went through and actually, you know, looked at the labels ourselves, or if there was a label recommendation, we cataloged that. And then we also, if there's not a label recommendation, we just tapped into our adjuvant expertise and tried to find the best recommendation we could. Actually, in our adjuvant guide, we have that cataloged per active ingredient we sell, per chemical we sell. We have it charted out to where you can just have that as a reference, and we also put it into the store. So when you go check out at the store, some of you might have seen this, where it just gives you, you know, this is the best recommended adjuvant that we think you should pair with this product. So it takes all the work out, and then if it's required, it'll actually say, instead of saying recommended, as you see there, it'll say required. So if it does say required, you know, okay, what's the label requirement? It's something that looks like I should probably use, and you don't have to call somebody or navigate the label or do any of that stuff. So it's really just an automated agronomy convenience thing there. Tank mixes are a little different story. Those are a little harder, but we're trying to figure out ways to account for tank mixes as well. So, you know, the hard part one is, okay, which adjuvant do I use with this product? And then hard part two is, well, now I gotta, instead of having a rate per acre, I gotta have this like pints per 100 gallons, and I got to rack my brain in the middle of the season to figure out how much of this adjuvant I need. And I have to do this math all the time, and it's a pain in the butt to kind of, I've got a calculator built in a spreadsheet every time I want to go figure out how much product I need. So within the acre packs, we made it really easy. And, you know, instead of needing that spreadsheet, when you order, you can just go, you know, okay, I'm going to go look and see what adjuvant I need. Then I can just go put the rate per 100, the number of acres. Then it's going to tell you exactly how much volume you need. So it's, and you can see the water, so you can put the gallons per acre. So if you're going 5 gallon work, 10, 15, it'll adjust the amount of adjuvant you need on a V2V basis. So really convenient. So those two tools, you know, good quality products, the tools you need to figure out the product, and then the tool you need to figure out how much you need. So tried to hopefully show you, you know, we tried to simplify the adjuvant space and really make it easy for you guys to do this. It's something, you know, in the middle of the season, the last thing you want to do is go navigate labels, do all this math and all that. So yeah, and with that, I'm gonna turn it over to Steve for a few slides here. Steve has spent 40 years in the adjuvant space. He was actually on the team that developed the first generic glyphosate formulation. So he lives and breathes adjuvants and knows more about it than just about anybody on the planet. So he'll tell you why quality matters and what the difference is. You know, you hear a lot of snake oil, or, you know, is this product actually good? There's, you know, expensive product, cheap product. How do I know what to trust or what to buy? So we're gonna let Steve, as the expert, give you guys the rundown on that. So I'll turn it over to Steve.
Thanks, Neil.
Yeah.
You got my mic on back there? Hopefully, yeah. So, if any of you ever wondered why, if a pesticide manufacturer thinks adjuvants are so important, why don't they just put it into the ag chem formulation itself? raise your hand. How many of you ever wondered that? Well, it's a valid question. But think about this for a minute. When you're selling a pesticide, you want to make that pesticide formulation as concentrated as you possibly can. If you're BASF or Bayer or Syngenta, or if you're in the generic business, you want to put as much active ingredient in that formula as you can get in there, which means there's not a lot of room for other things. Pesticide manufacturers that are selling fungicides, insecticides, herbicides, PGRs, they want as much active ingredient in that jug as they can get. So it leaves a limited amount of room to put the surfactant in, which is why today almost every pesticide, agrochemical, has some sort of recommendation on the label about adjuvant use, because it's critical. In the olden days, you could get by with it because they typically, they were weak formulas, and there's 2 pounds of active in a gallon or whatever it was, and they had plenty of room for the adjuvant. Nowadays, it's not that way, and that's why nearly all your ag chemicals have some recommendation for an adjuvant. How many of you put, say, 2 or 3 products in a spray tank when you make an application, or 4 or 5? Okay. Well, there's another reason why adjuvant use is so critical, because you got a lot of stuff in that tank. And it's crucial to have the right additive in there. You can have all sorts of problems. And Neil, if you would just go ahead and run this whole slide, put everything up here, because I'm going to come back to some points. So just run all the bullet points up at one time here, and let everybody can kind of read through these, because we're going to talk a little bit about what happens with surfactants or crop oils or multifunctional novel type adjuvants. And this talks a little bit about what goes on a farm if you use the wrong thing. And I guess the important question here is, why does this matter? And what happens? What can go wrong? I started out in this business driving custom applicator rigs. My family was in farming down in Texas for years. And I worked in distribution, retail, and then been involved in really all over the world. I've lived in London, Tokyo, and everywhere else, and all of it in agriculture and formulations, adjuvants, agrochemical business. And it doesn't matter if you're farming in Canada, it doesn't matter if you're farming in Alabama or Illinois, or if you're in Brazil or France or whatever. First of all, the farmer doesn't want to have to go back and respray. Second of all, he doesn't want to use a product that's going to cause trouble, particularly if it's an adjuvant, because that's, that's not at front and center of your mind when you're doing an application. You're thinking about the weed or the insect you're trying to kill, and you just don't want to have problems. You don't want to have to clean strainers out and stop, and tips are plugged up, and you got a wire and trying to job out nobody wants to mess with that. And so when you look at all the points here on this slide, all of these lead to some bad outcomes if you don't use the right product. If you've got an insufficient, good, homogeneous mixture of your spray in the tank, then you're going to be okay. You're going to be assured you've got even distribution of the chemical from one side of the field to the next. Oftentimes we have to shut down at night, and you got half a load left. You got to make sure it doesn't settle out. When you go back to spray the next day and you start the agitator up, everything goes back into solution properly. But if you've got the wrong adjuvant and you got layering out in the tank, then you may have part of the field you get the chemical on, but you don't get the effect of the adjuvant. Or even worse, you get some layering of the ag chemical itself. You start out on one side of the field, you get insufficient coverage of the chemical itself. And this is really critical when you're dealing with fungicides or insecticides, because with a herbicide, you can go back a week later and look and tell if something went wrong because the weed's not dead. But when you're dealing with disease spores or dealing with insects, oftentimes you can't tell what happened or what went wrong until after the fact, when you've already got, it's already affected your yield to a point at which you cannot recover. So that's why when you look at on this chart here, some of the things that happen. These bottom two down here are really important. When oftentimes you have people who are working for small local adjuvant formulators. The salespeople that come and call on you, the salesman doesn't know what's in the jug. He's just been told this is what we need to sell, or everybody says it's good quality, but they don't really know. That's why it's important to buy your adjuvants from a company that understands the importance of the architecture of the adjuvant and what goes in that jug, and make sure it's consistent from one year to the next, from one batch to the next. There are certain technology providers and adjuvants that we all know, and FBN has access to the best. And so we went through this whole adjuvant line, and we made sure that every product in this whole Farmers First lineup is not, there's no trickery or foolishness that goes on with the architecture of the products. You can always find something cheaper somewhere, but always remember this: you never get more than what you pay for. You'll never get more than what you pay for. But sometimes you'll get less. So when you look at, let's just take for example here, a 90-10 non-onyx surfactant. Here's some of the things that can happen there. You say, well, it's a 90-10 surfactant. What can be the difference? Well, it's how you build it. And when you're trying to put together a product, there's certain cost factors involved, and the real true surfactant is where the cost is. And any type of a 90-10 non-onyx surfactant, the stuff that wets is what's costly. The fillers are not, and so that's where the games are played, because you can say, well, how can they both be 90-10 when they're built different? Well, you take it to a lab and you evaporate and drive the water off, you'll have 90% of something. We saw one, Neil, the other day. Somebody sent us an example of one. We checked it and had formaldehyde in it. And I don't know about you, but embalming fluid doesn't have any place on my farm. And so, but that's an example of some of these fillers that go into it, or antifreeze, or glycols, and this type of stuff. And so, you don't want to go there. You got to deal with people that know what's in the jug, and at FBN, we know what's in that jug every time. Go to the next one. Neil showed you the time-lapse video a while ago of this. I call it kind of the coffee ring effect. When you look here at the standard non-onyx, you get a little bit of a migration to the edge of the active ingredient. But when this Enzorb Advanced, which by the way, has a sugar-based surfactant in it. It doesn't have any alkyl phenols, any of the stuff that's attributed to Aristide syndrome, and we don't have any of that in there. It's a sugar-based surfactant. And it makes sure that the active ingredient, when that droplet dries, that active ingredient, if you see up here, it's pretty evenly distributed all through that droplet as it's dried on the leaf, and that's what you want. And that's an example of what happens between a good one and a bad one. A bad surfactant, you just don't know. First of all, you don't know if it's even going to wet to begin with, and if it does wet, how long is it going to keep the droplet wet so that the active ingredient can be absorbed into the plant. Same thing with crop oil. You look here and you say, okay, what happens, how can you build an oil? What's different about it? And so, let's take crop oil concentrate, for example. A lot of you use crop oil concentrate, MSOs as well. But think about it. A lot of times you got something in that spray tank that doesn't necessarily like an adjuvant, like ammonium sulfate. If you got AMS in that tank, you're going to have to make sure that your adjuvant is compatible with an electrolyte, which ammonium sulfate has a charge to it. And the only way that you'll get an adjuvant, particularly a crop oil, to be compatible with ammonium sulfate is you've got to put a special surfactant, a coupling agent in there that'll bind together with ammonium sulfate. Again, that costs money. It's not cheap to do that. And so when you find crop oils that seem like a bargain, well, there's a reason that they are. And we'll show you some pictures in a little bit. In fact, right here, you can see, you want, there where it shows initial bloom, you really want to have some kind of the beginnings of showing that product beginning to emulsify. When you get some kind of hard layer on top, you're in trouble. The initial blend shows that just if you give it an initial shake, that's what happens. It mimics when you have agitation in your spray tank. You get this milky, homogeneous, looks like milk. Milk's an emulsion. That's what it should look like. And then the next question is, what happens over time? Because, it takes a time to get over the field. You've got some agitation, presumably, but in the case of a good, well-made crop oil concentrate, like implant COC, even without the presence of agitation, you still got this homogeneous emulsion an hour later, and there's no agitation. That picture at the end there, they didn't go back and shake it up. That's the way it looks after it's been sitting there for an hour. And that's what you want in an adjuvant. You start getting the layering out and the yellowing in these other ones here, that's going to happen in your spray tank, which means your adjuvant oil, as you know, floats to the top. You're going to have part of your field that your pesticide doesn't get any effect of the adjuvant because it's all floating on the top of the tank. So that's why quality matters, okay? Because that's the only way that you can be assured that you get the performance of the spray application. Here it shows there's like a split jar here showing the initial and after it's been sitting for a little while. And again, you got one of them over here that is already layered out. It's back to clear water in one side of it. That's not going to do much good. You need to have that. You need to have that milky emulsion look. Okay. The same thing on just instead of high surfactant MSO, you have the same issue with just a plain MSO, which a plain MSO usually has a little lower emulsifier level than crop oil concentrate, so it tends to kind of break a little quicker. But what you don't want is to have that almost clear look that you see in the low quality with that really orange layered out at top. But when you see that liquid become almost translucent and clear, that means you've lost your emulsion quality. And it's going to, again, affect the performance of particularly of your herbicide, because that's when most of the time when we're using MSO. Okay? So, one of the things that FBN has chosen to do is to participate in a voluntary certification program for adjuvants. In Canada, it's a little different because we deal with PMRA there. There's a regulatory protocol in Canada that's different from the United States. In the U.S., adjuvants are not regulated by EPA, which is why it's a little bit more of a Wild West affair when it comes to quality. But the ASTM, which is American Society of Testing and Materials, which is an authority on testing methods for everything from civil engineering to nuclear physics, there's an ag chemical group there. And I've served on that committee for 20 years now. And companies can voluntarily supply formulas and samples under confidentiality, and there's a panel that will review that and give it a seal of approval. And many of the FBN adjuvants have that ASTM CPDA seal of approval. So they've been vetted for authenticity. It means that, you know, the architecture and the build of the product is the right way. And finally, before I turn it back to Neil, there's always one other thing that I apply this test to any product that I ever put in front of a client. FBN's been a client of mine for several years now. I call it the dad test. My dad, who now deceased, I used to always, from the time I got in this business back in 1981, I'd always think, if I couldn't look my dad in the eye and say, you can use this product or recommend that you use this product, if I couldn't look him in the eye with confidence and say that to him, if I had any hesitation, even for a moment, I'd kill the product. I've never brought a product to any client ever that didn't pass the dad test. And every single product that we've got in this product line of adjuvants here at the farm, under the Farmers First brand, they pass the dad test.
Yeah, thank you, Steve. Appreciate it. You can stay up and answer. We'll do some Q&A, but no.
Yep.
Yeah, I think one thing we might touch on here, Steve, is just the regulatory environment and what that looks like. So there's no really it's the Wild West, as Steve mentioned, so there isn't any, when you go to the states, there's only seven states, right, Sophie, that regulate, 9, so I'm getting the technically, it's 9 states that regulate, so you can put anything in a jug. A lot of these games can be played to cut cost. There's not a lot of, in order for you to be able to tell, you know, well, is this a low quality, high quality? There's tests you can do, but you have to send them into a lab to really be able to do those, you know, and analyze them. So it's something where you just have to trust. You know, we tried to do a good job here today, just giving you, you know, we don't want to just say, hey, trust me, it's good. We wanted to give you the pictures, the evidence, you know, the justification behind it. So hopefully we accomplished that here today, just because it is, there is some risk to, you know, like Steve said, not everybody knows what's in their products or that kind of thing. So it's, I just want to make sure the big investment you spend in the crop protection is really protected. It's doing its job. We're not risking any performance. So it's really meant to be able to give you peace of mind when you're applying those products and make sure that they're doing the job. So Yeah, I guess anything else on the regulatory before we do Q&A, Steve?
No,
Yeah.
one thing though to remember, I was looking the other day at the Iowa State budgets for soybean and corn production, which encompassed all the crop input cost and fixed costs and land costs. And adjuvants constitute somewhere between 0.6% and 1.3% of the total budget for a farm. That's the wrong place to try to cut cost, because adjuvants can have a disproportionate and outsized effect on a very expensive, herbicide or insecticide or fungicide spray. It's just such a small part of the overall budget. The main thing is just always use the right product. Use it from someone you trust. You can trust these products.
Yep. Yeah, and it's our objective really with the quality and the pricing was just to have a good balance of quality and affordability. So we don't want to be the cheap, or probably not the cheapest, because we did the work to be able to put the components that are going to make them perform, but we're not trying to gouge, we're not trying to make a ton of, an oversized profit. So we just try to be reasonable as far as the value proposition, make sure that it's, good quality, just a good price without sacrificing quality is really the core tenet. Yeah, I hope we did a good job vetting that. If you have any questions, feel free to catch us afterwards. We have demonstrations down at the booth space, so we can do a little spreader, wetter adjuvant demonstration down there, have some visuals. And then we have a couple jars that you can see. If you shake them up, you can actually see the separation that we're describing here in real time. So if you want another visual, it's kind of cool just to see for yourself if you're curious about it. So with that, we can turn it over to Q&A if you guys have any follow-up questions, and we'll do our best job to answer them. We got a couple in the back there.
I've worked with hundreds of thousands of acres of applications with AMS, the dry formulation. Very effective, cheaper, and I hate it. Are any of your liquid formulations I still think it's the best product, the dry AMS, but any of your liquid AMS products, performance-wise, right there where the dry is, or better?
So the question would be, is the liquid, if we have a liquid AMS, are you talking straight AMS product or an alternative, like a low rate product?
About the standard or the straight AMS dry product, we always use that, and even like with Liberty and that kind of thing, with the 3 pounds per acre, was a lot more effective than anything we tried with the liquid. Well, we want to go away from using the dry.
Gotcha.
I think the compatibility is a little better using a liquid with the surfactant too.
Yep, so we have and I'll answer, and then Steve can comment. The even LR would be our liquid reduced rate product. The even DR would be the dry reduced rate. So those are going out about 4-to-1 roughly ratio of dry AMS to AMS. And then we have a liquid, even 34L would be the liquid AMS. So that's just a straight liquid AMS. And then we've got the even L Pro would be AMS, but it's got non-ionic surfactant and drift mixed in with it. So that's one of our, so if you want all in one, if you need a surfactant anyway, you can have it all in one shot. So those would be, as far as glufosinate, the one that's probably the toughest to get away from AMS altogether. You can mix the even DR and you have to supplement with some dry AMS. It's hard to get completely away from it, but with glyphosate, we're confident in the performance with the even LR and the DR to replace dry MS and be just as, we got some data shows on, it's, just as effective as AMS with glyphosate. I know, Steve, anything to tack on to that? Or is
well,
that, yeah.
Ammonium sulfate has always been the standard for a water conditioner. The problem is it takes so much of it. It's a logistical nightmare to handle. So every farmer has to make his own decision. Do I want to pump a lot of liquid or haul a lot of dry material? Because it works great. The limitation is it just, from a transportation and logistics and material handling standpoint, it's just tough. And so oftentimes some of the AMS replacement products, even if they're not quite as good as ammonium sulfate, the benefits of just the ease of handling and the performance difference, while it might not be quite as good, in some cases it could be as good, but sometimes it's not. But the performance difference will be almost insignificant. So it's really a personal decision by the farmer. Do you want to handle a lot of dry or liquid ammonium sulfate at the rates that you have to use it at to get an effect, or not? And every farmer is different.
Yeah, so the data we have on it's like 95 to 99% control compared to AMS. So it is like we're not claiming it's better, like Steve said. It's, close to as good.
It's
just
close enough
close
to
to as
work.
good as. Yeah, exactly. So we'll have, hopefully that answered. If it didn't, we can catch up after. Yeah.
Can you clarify a little bit adjuvants for fungicides, and in particular corn fungicides? There seems to be more finesse, more particularity on corn fungicide adjuvants. What ones are recommended to use and why, and what ones are not recommended to use and why?
Yep. Yeah, so
Typically, the sensitive issue around corn fungicides has been, back several years ago when we had problems with arrested ear syndrome, and nobody really knew what was causing that. And I don't know the definitive answer. You look at research from, different universities. One of the culprits seems to be the use of material called nonylphenol ethoxylates that are commonly used in non-ionic surfactants. And they're also used in emulsifiers for crop oil concentrate and MSO.
Yeah, and Steve, you might explain. I think there's a lot of like NP, AP. It might be worth explaining.
Yeah.
Okay, yeah.
So when you look at this material, it's typically called a nonylphenol ethoxylate or an alkyl phenol ethoxylate, and a typical acronym is an MPE or APE. And those were pointed out as possible culprits for arrested ear syndrome in corn. And so there was a movement here to try to get away from those kind of materials, and a lot of companies did. But like anything else, when you move away from MPE or APE materials, you increase the cost. The reason that those materials are used in the first place is it's the cheapest way to get a wetter. So, naturally when people build products, they want to try to build it as inexpensive as possible and make it more affordable. But that was the reason of all the concern about certain surfactants used in corn, is to get away from those that use MPE or APE materials in the formulation.
Yep. Yeah, so the two products, we have two, there's an Inzorb 90 then an Inzorb ADV. So the Inzorb 90 is going to be more your lower cost table stakes surfactant, and then the ADV is the one we went through with the time-lapse video, all that stuff. That's going to be APE free, so that's a sorbitan ester sugar base. So it's not an alkyl phenol, is a byproduct from the oil and gas industry, right, Steve? From the yep. So it's, instead of using that material, we're using a sugar base to be able to, and then it doesn't have the APE, and that's safe for corn fungicide. So that's the one we'd recommend. It'd be the Inzorb ADV, and then you can also use the field grip if you want to get some drift control. So the combination of those two is going to give you a really potent, good combination for corn fungicide. In addition to like a typical non-ionic is going to be a spreader wetter. The additional benefit with the ADV is there's evidence that it'll actually help carry the fungicide into the plant. So you get a penetrant activity as well. So instead of just spreading it across the leaf, you're actually helping to carry it into the leaf with that product too. Anyway, Inzorb ADV and field grip DRA is the recommendation on that. Yep.
I'm from, excuse me, I'm from southeast Missouri, and in our area, water is exceedingly cheap. But one thing we do have issue with, I know you had a slide on pH, but there's a lot of dissolved mineral content. Our area actually has a lot of iron in the water. Then you go over to Kentucky, there's a lot of dissolved calcium. Through your experiments, have you seen anything obviously well water, because that's where the dissolved material usually is, that really kind of is a common thread through experiments that interferes?
You want to take that one?
Yeah. So what was the heart of the question there?
So the question is the iron, was it, you said, what were the minerals you were
yeah, dissolved mineral content that interferes with application, where you've seen the chemistry go wrong with interference.
Well, anytime you've got minerals in the water, it's well known that it can interfere with glyphosate activity, and so the challenge is how do you render either salts or positively charged minerals like zinc or manganese or iron, how do you render those ineffective? And that's why we've got an assortment here of water conditioners, some of which are based on ammonium sulfate and some that aren't. And I don't know if it's quite as big an issue when you're doing insecticides. Back in the day when we had organophosphates, pH was a big issue because it would hydrolyze or break down organophosphate insecticides. We don't use a lot of those anymore. But typically with herbicides is where you get the biggest negative effect, where water quality does manifest itself. And so anytime you've got a pH issue, I mean, obviously not everybody is sitting on a water well, a neutral water that doesn't have minerals in it. I don't know if one of those has ever been invented, but particularly if you've got any sort of a pH issue and where you've got the presence of manganese or iron or calcium or zinc, it's pretty much standard practice to make sure you use a good water conditioner.
Yep, and as far as if there's more, just using more to get more binding sites with the water conditioner is gonna, it's just upping the rate. If you have more dissolved mineral content than others, I think it'd be we don't have anything specific for iron or specific minerals, but just upping the rate of the water conditioner, the worse the conditions are.
The labels are usually written for that. It'll have a range of rates on the label. If you're in really severe water, use a higher rate. But typically, the mechanism whereby a mineral is sequestered or rendered, where it can't interfere with your pesticide, that mechanism's the same whether it's calcium or zinc or iron. It really is not specific to any one particular.
Yeah, so just the number of binding sites in the adjuvant so that it can capture more of the minerals, that would be the thing that you can adjust for. Cool. Yeah, any next question? Anything? Hopefully that answered.
Okay, so you were talking about the sugar-based adjuvant and things like that. I've heard of some guys that have just used sugar spraying out on their fields, stuff like that. I think there's a benefit as far as that goes. Do you see that as an advantage just from a surfactant scenario, I guess?
Oh,
if I'm making that clear?
Yeah, I'm glad somebody asked. That's a good question there. Keep in mind that a sugar-based surfactant is different than putting molasses or sugar or raw sugar in there. Completely different issue. In the case of N-Sorb Advanced, we're using a sorbitan, which is a sugar alcohol. And then it's reacted with ethylene oxide, which makes it have both a water-loving and an oil-loving end to it. That's how surfactant works. It joins, between oil and water. And so the phenomenon of how a sugar-based surfactant works is different than someone that's putting corn syrup or sugar or molasses in a formulation. It's a completely different phenomenon. I don't know if that answers the question or not, but a sugar-based surfactant is basically a sugar alcohol that has been reacted to another element that helps it have both a water-loving and an oil-loving end to it, which is, and just plain sugar doesn't do that.
Yeah, so it might have some, like you might get a little better spreading, but it's not going to have the same overall quality or activity as so I wouldn't rely on that as a standalone surfactant by any means. Because it has to go, get to the state where it has to go through a reaction. There's a whole process to get it in the alcohol form Steve's talking about, so. Yep, okay. I think we're all wrapped up, so appreciate everybody's time today. Hopefully that was informative, and we'll be around if you have any follow-up questions or want any more info. So have a good rest of Farmer to Farmer. All right, thanks.
Thank you.